Okay, this is the simple cycler modification where I've replaced and removed the LCD screen and the logging output port to make the device even cheaper and simpler to assemble and construct. In order to facilitate this, I've added a bi-colour LED, which you can hopefully see here. It's one of the two wire connectors, two wire connection types. It's a red and green bi-colour LED, changes colour depending on the direction of current flow through the device. Now, to operate that, all you have to do is you have to add two 330R resistors as a potential divider between pin 1 and pin 3 of the LCD output port. Join those together, and at that join point connect the green wire, which goes to the long wire on the LED, and an orange wire which goes to the middle connection on the 3-pin connector here. So that basically gives you the LED functionality. Now, there is a current limiting resistor on the board. It's a 330R R4 there. Now, that can be safely removed, and that will just give you a slightly brighter LED. So if you want to remove that, you can do that. Just put a wire link in there instead. So that's the only modification to the hardware that's required to allow the LED functionality. So I've loaded this version of the cycler with my new simpler code. So I'll just turn it on. So when you first turn it on, let's do that again just so you get an idea. I'll just turn it on in a second. So when you first turn it on, the LED that you may have noticed just flashed briefly red and green there for a second or two, just to show it's powering up, and then it goes off, and it will remain off and until you activate the cycler. Now, in its present condition, if it's connected to a battery with the normal crocodile clips here onto an HV Insight G1 battery, and the main switch is in the off position, so there is no high voltage. Now, in this situation, pressing the button does nothing. You can't activate the cycler unless it's connected to a battery, either discharge or charge mode. So that's a safety feature. If it can't detect any voltage coming into the unit, then it won't switch on. So that's useful. However, as soon as you turn the HV on the main switch on the battery, then the LED begins to flash. You can see that, and it will continue to flash all the time that HV is present. Unless it's actually charging or discharging, which it will either be green or red. So you always know that if the LED is flashing, you know that there's HV potential on the system. So now, to activate the charging mode, you basically press and hold the LED until the green light comes on. Release it. That's mode 1. On the board now, we now have the green LED lit, indicating that it's charging. And it will charge now for 24 hours or until the voltage exceeds the threshold, I think, which in this case is 180 volts. So it will just basically charge for 24 hours. That's a good soak charge. And to cancel that, just press the button, it goes off again. You'll notice the LED remains flashing because it's still connected to the live HV battery. And to go into discharge and cycle mode, you press it down until the red light comes on, release it, and you'll now see on the board the red LED is on. So now it's now started the 30-hour discharge cycle, and it's using the fixed 300R load. If you wanted to be a slightly less aggressive with the battery, you could use a 400R load. 300R seems reasonable because the current drops right down to very, very little by the time the voltage drops. So it will drop away now. The voltage will go down to at least around 10 volts before the unit shuts off the discharge. So it will either continue to discharge for 30 hours or until the voltage of the system goes below 10 volts. Once that's done, it will automatically switch back to the charge mode and then charge the pack for 24 hours or until the voltage exceeds 180 volts. So that should give it one very good full cycle and a good depth of discharge. So again, to cancel the discharge mode, just press the button, and it's flashing again to indicate that the system is still live. So if I turn the HV battery off now, you'll find the LED goes out, indicating that the system is now safe to handle. No HV present in the charger, apart from obviously the mains input and on the DC side. So if I turn it back on again, starts flashing again. I go into charge mode this time. Charge is activated. Now charge, as I said before, for 24 hours until the voltage exceeds 180 volts. Now if I turn the power main switch off now, while it's in the charge mode, the charger will go off, and even though the HV battery is now off, the LED will continue to flash as the power capacitors in the charging LED drivers discharge down to a safe voltage. So that will remain on until the voltage drops below about 10 volts. So that's another safety feature. So that's it basically, the simple cycler, now even simpler. One LED, one push button, that's your controls, 300R fixed load to give a nice tapering discharge, 2 LED power supplies. If you're making this up yourself, I suggest you put these here to occupy this space and this space, and instead of having a little jumper wire here, you put the jumper wire here. Basically it's exactly the same configuration, it just moves though these rather noisy supplies slightly further away from the electronics at this end, but it seems to work fine. The only addition I've made to this one, which has been discussed before, there is a 0.1 UF capacitor across the switch, and that's basically from the negative to the switch input, and that just prevents spikes resetting the PIC, which is what was happening in some of the devices earlier on. So there we are, that's the simple cycler, and I hope that proves interesting. I'll upload the code and you're welcome to have a go with it.